All right, you guys at home, this is posted in today's folder, this worksheet. So I'd print it out first, and that way you can follow along. 1A, determine which graph shows the solution of the initial value problem without actually solving the problem. Okay, so that seems kind of a weird a weird question. Solve the problem without solving the problem. So number 1, it says the slope is equal to 1 over 1 plus x squared. So rather than, there's one way to do this would be to integrate that and figure out what y is. But this is saying don't do it that way. Use this to find some slopes. Use this to figure out, make sure it goes through that point, and kind of go from there. So let's check the point first, because that would be the easiest thing to check. So that means I need to see if any of those graphs don't go through 0, pi over 2. Yeah, well, that didn't help, because they all go through 0, pi over 2. So my next thing is, well, let's check the slope somewhere. So dy dx, let's check x equals 0. That should be an easy spot to check. So the slope at x equals 0, 1 over 1 plus 0 squared, is 1. So that's the slope at x equals 0 is supposed to be 1. So now you look at your three options. Which one has a slope of 1 at x equals 0? B. I mean, I don't know that it's exactly 1 from that picture, but this one has a slope of 0. This one has a slope of negative something. So those can't be it. This one has a slope of 1. Or at least it's positive, and it's the only one that's positive, so we'll assume that it's 1. It can't be A or C, so it's got to be B. So we used a picture to kind of answer the question without really solving this differential equation. So slope fields help us solve differential equations. Tomorrow we'll actually solve that, but today we're just going to use slope field pictures. By the way, does that look familiar? Can you think of a function whose derivative is 1 over 1 plus x squared? I hope so, because we did that yesterday. So inverse tangent of x plus c if we took the antiderivative of that. Now that doesn't really help us because most of us don't know what the graph of the inverse tangent looks like. Yeah, it looks like that right there apparently. Number 2. Same type thing. 3 graphs. I don't really want to solve this. I'd rather just check and see. I think it has the same issue. They all go through negative 1, 1. So that's not really a help. Let's check the slope at 0. So the slope at 0 is 0. So does that help? Semi, that's a good answer. Which one can I throw out? A, because that has a slope of negative 1, or at least negative something. So it can't be that one. These two both have a slope of 0 at 0. So it could be B or C. So let's pick a different point to check the slope at. So dy dx at x equals, what do you want to pick? 2? 2 works for me, so let's check the slope at 2. So if I plug in x equals 2, I get negative 2. So I don't even know exactly where 2 is on this graph, but I do know that this one has a negative slope, and this one has a positive slope. So this one, it's got to be graph B. You should have just checked with negative 1 or 1. But 2 was fine too. It didn't matter. I mean, I see why you might want to check with -1 because that point is labeled. But it would still, it would still work. So the slope at -1 would be +1, and that fits right there. So there was multiple places to check to see that it worked. This one we could also antiderivative. Running out of space here. If I take the antiderivative of -x, what do we get? Now forget the pictures. Yeah, I need a plus c. Right, antiderivative -x. -x² over 2 plus c. And so I don't know the plus c without more information, but the only one of those pictures that could possibly be -x² over 2 is b. Now that's not how they told us to work the problem. That's basically what we'll do tomorrow. So today we're going to use pictures. Tomorrow we'll do antiderivatives, and then hopefully see how they work together. All right, number 3. That picture looks crazy. Let's see what's going on here. The slope field for dy dx equals 2 minus y is shown. So they're giving us a slope field. We don't really know what that means yet, but as we work this problem, we'll learn. Where would the solution curve have a horizontal tangent? Okay, well, forget the picture. Just tell me what a horizontal tangent means. Okay, I saw this. That's good. What else? Can you give me something with a little more mathematical than what equals 0?
X equals 0.
I don't know that y equals 0 or that x equals 0. But something equals 0, because I don't know where the graph is. It may not be it may be like up high where y equals 7. Y prime equals 0. Or dy dx equals 0. That's what a horizontal tangent means. So I look at this equation, and if dy dx is 0, so I plug in 0 for the slope, and I get y equals 2, which looks like a horizontal line at y equals 2. But we'll hold that thought for a moment. Part B. Sketch the solution curve having an initial condition y equals 1 when x equals 0. All right, we don't know how to sketch the curve yet, but we can do an initial condition of y equals 1 when x equals 0. So 0, 1. Let's start there. And by the way, the next 3 I'm going to do in 3 different colors. So at 0, 1, that would be, it's hard to see the x and y axis on this, but there's the x and y axis right there. So at 0, 1, that would be right about there. X equals 0, y equals 1. All right, here's our 2 rules on how to sketch. The first rule is advice never given to teenagers, and that's just go with the flow. Just kind of follow the pattern. Just what everybody else is doing, just kind of go that direction. Right? That's terrible life advice, but it is how you graph a curve when you have a slope field. And then sort of to phrase that differently, never cross slope field lines. So that's sort of the same thing. Go with the flow. Don't cross anybody. Just kind of go along to get along. Just kind of follow the current wherever it leads you. Again, not real good advice. in general, but it's how we graph slope fields. So I'm going to start at 0, 1. It looks like I'm just kind of flowing this way, but I can't cross that line, so like that. And back the other way, kind of just flowing down like that. Just kind of follow the path. Part C. Sketch the solution curve having an initial condition y equals 0 when x equals 1. So I'm going to start at 1, 0 for that one. So about right there. And again, I can always parallel to the nearest slope field line. Don't ever cross one. Just kind of go with the flow. Part D. Sketch the solution curve having an initial condition y equals 3 when x equals 0. So I'll start at, whoops. No, that was right. 0, 3. So 1, 2, 3. So this one starts above that horizontal tangent line thing. This one's got a little more room to follow, so to the left, again, don't cross any lines, just kind of go with the patterns that's there. And to the right, sort of angles down into that. I guess that thing turns out to be an asymptote because everybody gets closer to it. I sort of just answered part E. What can be said about the long-run behavior of y? For example, does the limit as x goes to infinity of y exist? If so, what is the value? So limit as x approach infinity of y. So as x gets really, 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 really big, it doesn't really matter where we start. What does our y value go to? To 2. Now, we don't yet know how to solve this guy. Like we solved the previous two, they were relatively easy because you recognized inverse tangent for the first one. This one was just the power rule. This one looks a little crazy. So we're not worried about that one yet. Maybe we'll do that one tomorrow. But it illustrates that with slope fields, you can get kind of a picture solution, even if you can't get an analytical solution. Even if I can't solve that, I can at least know what the answer looks like. 4 and 5. Are the graph slopes a function of x alone, y alone, or dependent upon both x and y? So that means, does it depend on x? Does it depend on left and right? Or does it depend on up and down? Or does it depend on both? So looking at number 4, I guess let's check x first. So as I move left and right, do the slopes change? So it depends on x. For y, as we move up and down, so look at just like a column of answers. Do the slopes change as we move up and down? Look at a column of slopes. It doesn't depend on y. Pick any different x value, but it doesn't depend on y. As we move up and down, the slopes don't change. As opposed to if we move left and right, they're changing. So that one depends. Finish my thought here. So if we move up and down, the slopes don't change. So those slopes depend only on x. If we move left and right, they change. If we move up and down, they don't change. How about number 5? Does it depend on x? Pick out an x row. Do they change left to right? Nope, all the slopes are the same left to right. So it does not depend on x. How about y? Does it depend on y? Definitely. You pick out any column you want. You move up or down, they're changing. So it depends on y. So our conclusion would be the slopes depend only on y. See why this matters in a little bit when we get to some multiple choice questions. All right, let's draw our own slope field. And, let's read the thing here. In the section, we can solve differential equations by obtaining a slope field. I've never heard it called a direction field, but slope field for sure. That approximates the general solution. So the slope field tells you sort of what the graph looks like without actually having the graph. So let's do dy dx equals y. So let's fill in the chart for dy dx, and then we'll use this chart to make the graph. Oh, I don't like this. It doesn't tell you which one's x and which one's y. But since y is usually the up and down variable, let's say those are the y's, because that sort of matches the graph. And those going left and right are the x's. So in this top left corner, y is 3, x is negative 3, dy dx is equal to y. So dy dx is equal to 3. If y is 3, dy dx is just 3. Right, let's move over one. These are going to go real fast here in a minute when we pick up the pattern. If x is negative 2 and y is 3, what's the slope equal to? What's dy dx equal to? 3. Because the slope only depends on y. In fact, it is y. So if I move over here to negative 1 comma 3, dy dx is equal to y, but y is 3, so my slope is 3. You get the pattern for this row? Not much of a pattern. Y is 3. If y is 3, then the slope is 3. This next row, y is 2. If y is 2, the slope is 2. It doesn't really matter what x is. So all of those are 2. The next row, y is 1. The slope is y, so the slope for all of those is 1. Oops. On a test, you're never going to have to fill out a 7x7 grid. So that's 49 answers we just gave. They were all easy. There was a pattern, but it was 49 different points. All right, now I want to use those slopes to make a slope field. So the slope field is you put just a little slope piece at the point. So right here at negative 3, 3, negative 3, 3, that's this point. My slope is 3, so that's pretty steep. In fact, you kind of just aim for, so that would be down 3, back 1, but I don't want to draw the whole thing. So my slope of 3 maybe looks like that. In fact, the aiming at idea is, there's a better way to say it because that one's got a point I can aim at. So if the edge of my post-it note here is, from this point, is 1, 2, 3 over 1. So that has a slope of 3. Obviously, I don't want the whole thing. I just want a little bitty piece of a slope right there. In fact, all of those places where y is 3, the slope is 3. So I'm going to do a slope of 3 at all of those. And all of those should be parallel. That's pretty good. All of those have a slope of 3. Let's see, the next line down, when y is 2, the slope is 2. So still kind of steep, but not as steep as what we were just doing. So as best you can, a bunch of little slope pieces that are steep, but not 3 steep, 2 steep. Next line down, when y is 1, the slopes are all 1. So this is kind of easy to do. I'm just aiming for the next dot that's up and over. Right? Up 1 over 1. When y is 0, the slopes are 0. It's a little bit harder to draw, I guess, because it's on the x-axis, so you can't really see them. When y goes to negative 1, all our slopes are negative 1. So again, little slope pieces that have a slope of negative 1. Next line down, they'll have a slope of negative 2. Again, if you've got a ruler or a straight edge, you can make it have a slope of negative 2. Because you're just aiming at one that's up 2 over 1. And then that last one, the last row, when y is negative 3, the slope is negative 3. So that's an even steeper slope. Now we have this cool looking picture. The nice thing about slope fields is, even if they get really complicated, they all follow a pattern. And so if one of the slope pieces is out of place, usually you recognize it right away because it just looks like, wait a minute, that thing's pointing the wrong way. So usually when you finish, you step back and you say, oh, that makes a nice pattern. It must be correct. It doesn't guarantee you got it right, but you can certainly spot an error if there's one that's out of whack. Find the solution going through. Again, I'm going to pick 2 different colors because these are going to look different. So let's start at 1, 1. And again, we kind of just Follow the path. I know what the slope at 1, 1 is. It's 1. Then I start curving up. Don't cross any slope field lines. Run parallel to the nearest slope field line is another way to say it. Something like that. Then pick a different color to start at -2, 0. What's that line going to look like? What's that solution going to look like? If I start right there. It's going to be a horizontal line. Kind of a boring solution. Let's skip number 2 and go to number 3, because we'll use number 3 tomorrow So number 3 we'll solve. We may do number 1 as well, but we'll definitely do number 3. We'll solve it analytically tomorrow. Today we just want to do the slope field for it. Let's see. Ooh, this one we got to be a little more careful, because this one depends on x and on y. Thank you. Okay, so if x is -3 and y is 3, what's the slope going to be? 1. -3 over 3 is 1. I suppose you could plot the slopes as you go, but I think it would be much better to fill in the table and then put the table on the chart, because the table's going to have some symmetry and patterns as well. So let's do the table, completely do the table, and then we'll go to the chart. All right, if x is -2 and y is 3, what's my slope going to be there? 2/3. And then 1/3. And then 0/3. And then -1/3, -2/3, -3/3, which is -1. So a little bit harder than number 1, but there's still a pattern there. And the pattern is -x over y. So -3 over 2. 3 over 2. -2 over -2 is 1. 1/2. 0. -1/2. -1. -3/2. See, next row, always x over y, but with a negative. So that'd be 3. X over y. Oh yeah, if y is 1, this is good. 2, 1, 0, -1, -2, -3. What about if y is 0? Undefined. In fact, if y is 0, I'm going to kind of cheat and just do it this way. Undefined all the way. Now be careful, the undefined doesn't mean like nothing. There's a specific undefined slope looks like something. What does undefined slope look like? Yeah, up and down. So when I go to graph those, you don't just say, oh, undefined, I can't do that. Undefined has a specific meaning, and it means that it's vertical. So when x is 0, all of my little slope pieces will be vertical slope pieces. All right, keep going. I'm going to pause the video. If you're at home, pause it, finish it out, and then check it when you're done. Compare your answers, and then let's plot those little slope pieces. This one's a little trickier because they're all different, so just have to be super careful. So at negative 3, 3, my slope is 1. At negative 2, 3, it's 2/3, so that's a little bit less than 1. And then at negative 1, 3, it's 1/3. So positive, but even less steep. And then when I get to x equals 0, the slope is 0. In fact, I don't think it's shortcutting to just say, you know what, when x is 0, all the slopes, well, not all the slopes, 0, 0 is still undefined, but all the other x equals 0s have a 0 slope. And while I'm in all the y equals 0s are undefined. Yeah, we said undefined meant vertical. So those slope pieces are easy. All right, let's go back to working our way across the y equals 3 row here. So when x is 1 and y is 3, our slope is negative 1/3. So aiming down, but just barely down, negative 1/3. And then negative 2/3, and then negative 1. Next row. At negative 3, 2, our slope is 3/2. Or that's 1.5 if that helps. So there's a slope of 1. I just want to tweak that up just a little bit. Next one over is a slope of 1. I like that. That's an easy one to do. Slope of 1/2 is not hard to do. On the other side, let's see, negative 1/2, negative 1, and then negative 3/2, a little bit steeper than negative 1. And again, you start to see a pattern here. The row for y equals 1, that should be kind of an easy one to do. A slope of 3, so that's really steep. Slope of 2, slope of 1. Negative 1, negative 2, negative 3. It's kind of cool looking. Y is negative 1, slope of negative 3, negative 2, negative 1, 1, 2, 3. Figure out what shape this is going to make? It's certainly looking like a circle. Negative 3/2, negative 1, negative 1/2, 1/2, 1, 1.5, negative 1, negative 2/3, negative 1/3, 1/3, 2/3, 1. Now, on the test, I am not getting a ruler out and checking all of those. I'm going to take a glance at it and say, oh, the pattern is right. They're right. I'm not getting out a ruler and saying, oh, well, that was supposed to be 1/3, but that looks like 1/4, so I'm going to take off a point. Like, no, I'm not. I don't have the time to do that, and that's not the point of these. Let's graph a couple of these and see what it looks like, although we think we know the answer already. Let's start at 1, 1. Again, kind of follow the pattern. So I'm going to start out going to the left, but when I cross the y-axis, I better be parallel, or I better have a slope of 0. based on the symmetry of this thing, I'm going to guess that I'm going to go through all the 1-1s. And again, a second color might be helpful, although these aren't going to intersect, so you might be okay if you didn't. -2, 0, be over here. And again, based on the symmetry of this picture, I bet I'm going to go through all the 2's. Sure looks like a circle. Tomorrow we'll solve that thing more precisely, and we will indeed have a circle. All right, let's skip over to so we're going to skip 2 and 3. We'll come back and look at 1 and 3 tomorrow, or skip 2 and 4. Your homework is this page, is basically the rest of it, but it starts to go quicker. So flip to the page that starts with match the slope fields. Now, we're not experts at this by any means. So here's 7 through 10 are down here. Here's our options up here. dy dx equals sine of x. Well, without, plotting specific points, which one of those sure looks like sine of x? C. I mean, because sine, and maybe we should think backwards a little bit, that means y would have been negative cosine, but that's kind of the same thing as sine in terms of what the graph looks like. So that one's not bad. The rest of these we're going to have to be careful about. And one way to find them is to think about what we did a while ago, is that does it depend on x or y or both? So we knocked out the easy one, the sine of x one. Depends on x or y or both. I think let's start with number 10, because that looks to be the easiest one. So number 10, dy dx equals x. So that depends only on x. In fact, number 9 depends only on y, and number 8 depends on both. So if I'm careful, I can probably eliminate them based just on, does it depend on x or y or both? So number 10 depends only on x. That means as I move left to right, the slope should change. Phrase it this way. Slopes change as I move left to right. So it's not A. So number 10 is not A, because that doesn't change left to right. B changes left to right. But D also changes left to right. Which one do you think it is? B or D? Why B? Yeah, because D is changing both directions. I don't know how we want to label these. 7 is C, 10 is B. Speaking of D changing in both directions, what does that mean in terms of 7, 8, 9, or 10? That's got to be number 8. Number 9 depends only on y. A depends only on y. So 9 is A. Now, the next set's a little bit harder, because you got 2 that depend on x and y, so you may have to pick some points. Try a 1-1 or a 0-0 is hard to tell, so maybe don't do 0-0. But pick some points and process of elimination. Let's look at number 17, and then we'll be done, because there is one like 17 on the test. Consider the differential equation given by that thing. Sketch a slope field. Okay, that's just plugging in points. Let f be the function that satisfies the given differential equation. Write an equation for the tangent line. Okay, we've done that before. We just need a slope and a point to the curve through the point 1, 1. Okay, that's good news. So I'm halfway home now. Point's 1, 1. Use your tangent line. Okay, let's not do that yet. Let's write an equation of the tangent line. It gave me the point. I want the slope so that I can write a tangent line. How am I going to find the slope at 1, 1? What's dy dx mean? Slope. So my slope would be dy dx at 1, 1 is 1 times 1 over 2. So 1/2. So my tangent line then is y minus 1 equals 1/2 times x minus 2. We've done slope lines, tangent lines before. We're just not really in this context, but it's still the same thing. Find a point, find a slope, make a tangent line. Then use your tangent line to estimate the value of f of 1.2. So that means when x equals 1.2, what does f equal? What does f approximately equal? Well, I'm going to plug in. So y equals 1/2. Oh, wait a minute. I wrote that down wrong, didn't I? That should be x minus 1. If I solve this for y, I get 1/2 x minus 1 plus 1. So if x equals 1.2, then y approximately equals half of 1.2 minus 1 plus 1. And in fact, you could safe stop that and leave it that exactly like it is. Let's see, but 0.2 divided by 2 is 0.1, plus 1 is 1.1. This is estimating values that are close to points we know if we also know the slope. There's a fancy name for that. There's a whole lot going on that you can use that for. We'll stop there. All right, so your job is to try the best you can on the rest of this worksheet. You can pass on 2 and 4 on the classwork, because that's just more of the same stuff. So 1 through 6, you draw your own pattern. The next page is just matching. 15 and 16 is multiple choice with the slope field. And then try 17 and 18, and we'll go over them tomorrow.